Let's look at the esters homologous series. So the functional group is called an ester, and this is R, COO, R dash. So you have alkyl chains on both sides. They can or cannot be the same. So R dash can be equal to R. So esters name end in O8, and when you're forming esters, actually there is the reaction of an alcohol and a carboxylic acid. This is how esters are formed, if you still remember from your IGCSE. So the alcohol, actually an alcohol will contain the OH. So for example, CH3, CH2OH. Okay, so here it is. That's the molecule. I've shown it like this so that it's easier for me to show the formation of the esters, but the OH can be on this side as well. And the second molecule that will add to this is a carboxylic acid. So this is going to react to a carboxylic acid. Let's say we are reacting it to ethanoic acid. So 2 carbons, and then one of the carbon will contain the COOH, like this. Now what happens when you have the formation of an ester is that the carboxylic acid loses the OH and the alcohol loses the H, so that H2O leaves the molecule. So what you end up with is having, so this is gone, which means that this carbon now links to this oxygen. So there's a bond between this carbon and this oxygen here. So we end up with that molecule here, like this. So an ester contains 2 parts, an alcohol part. So the part which is attached to the single bond O, so you spot the single bond O first. Whatever part is attached to the single bond O, this is from the alcohol part. And the part that is attached to the C double bond O here, this is the carboxylic acid part. And whenever you're naming an ester, you will always name by starting with the alcohol part, then the carboxylic acid part, and finish by O8. So this is how you name a carboxylic acid. So the alcohol part here is ethanol. So you will have ethyl, and the carboxylic acid here is ethanoic acid. So ethyl, ethanoate. So ethyl is from the alcohol, ethyl again, carboxylic acid, and then O8. Here, let's try to name this one. So when you look at this ball and stick diagram, so this is the double bond O. So you can see that here, this is the carboxylic acid, and this part over here, so single bond O, this is the alcohol part. So when you're naming, you will always start with the alcohol. So alcohol has 1 carbon, so this is methanol. And then the carboxylic acid has 2 carbons, so this is ethanoic acid. So that the name of the ester is going to be methyl ethanoate. So you start with the alcohol first, so methyl, and then ethanoate. Ethanoate, so you can also remember it in this way, that the carboxylic acids generally form salts. For example, hydrochloric acid form chloride, sulfuric acids form sulfate. So carboxylic acids form, so for example, methanoic acid will form methanoate, ethanoic acid will form ethanoate, propanoic acid will form propanoate. So it's an acid, so it will have its corresponding salt. So the second part of the name is just the salt that is from the carboxylic acid. But an ester is not a salt. Far from that, there is no metal part in that. So it's not a salt. It's just for you to remember the naming. Let's see another example. So here I spot the double bond here. So because it's the double bond, so it's the carboxylic acid. And this one has the single bond O, so this is the alcohol. When I name, I always name the alcohol first. So the alcohol here, 2 carbons. So ethanol. And the carboxylic acid has 1 carbon, so methanoic acid. And when I'm naming, I will name the alcohol first, so ethyl methanoate, because the methanoic acid will form the methanoate salt. Okay.